Today, we're going to take a look at sine and cosine. Let's go. In today's video, I'm going to take a few minutes to explain the concepts behind sine and cosine, and then I'm going to show several examples of things that you can do with these nodes in a shader in both Unreal and Unity. Alright, so let's get started. So to understand sine and cosine, we start out with a circle with a radius value of 1. If we place a point on the circle and a point in the center, we can create a line like this. And then if we measure the angle between this new line that we've created and our original value, we can get this angle value here. This angle value is what we pass into the sine or cosine node when we're using it in a shader. So we give the sine or cosine node an angle value, and then it computes the sine or the cosine. Now the sine value is this line here. Notice that it's perpendicular to our original value or our original 0 angle line, and it forms a 90-degree angle here, connecting with the point on the outside edge of our circle. So the length of this line is our sine value. We can also create a line from our point that is perpendicular to this new angle here, and this value is our cosine. The length of this line is our cosine, and the length of this line is our sine. Okay, I want you to notice a couple of things. As our angle value approaches 0 here, the length of our sine value also is 0, and the length of our cosine gets closer and closer to a value of 1. But as our line here grows closer to 90 degrees, as this angle gets closer to 90 degrees, our cosine shrinks and gets closer to 0, while our sine value increases and gets closer to 1. And then as we come around the circle, on this side, our cosine value gets a negative length, and its maximum it's -1. And then our sine value gets closer to 0 again. So sine and cosine have this oscillating value between -1 and 1 as we go around the circle, and they're offset from each other by 90 degrees. Let's take a look at what this looks like in motion. So I want to give a big shout out to Freya Holmér, who gave me permission to use this beautiful animation to illustrate how this works. It makes it so easy to see what's going on just by watching it for a minute. I'll put a link to Freya's channel down in the description. Go and check it out. She has some amazing shader content on her channel as well. Okay, so now that we've seen how sine and cosine work and what we're measuring with these values, let's take a look at a couple of examples of how we can use sine and cosine in a shader. Alright, for our first couple of examples, we're going to be taking advantage of the fact that sine produces an oscillating waveform. And so in this first example, this is kind of a really simple, basic example. We're going to be passing time into our sine node. And what this is doing is time is being used as the value for that angle that we saw in the animated graphic. So as time increases, the length value of our sine goes up, and then it comes down, and then it goes up, and then it comes down. And remember, we looked at it and the value was oscillating between 1 and -1. So it would start out at 0, go to 1, go back to 0, go to -1 again. And so what we have here is we're passing the time into sine. And if I just show the result of this, what you'll see is this value is going between 1 and -1. And so over here in our preview, you can see that we go to 1, and then we go to 0, but now we're in -1 territory, and we can't see negative values in our preview. And so what we're going to do to fix that is adjust our range just a little bit, so that instead of oscillating between 1 and -1, we're going to oscillate between 0 and 1. And the way that we're going to adjust our range is by first multiplying by 0.5, and that shrinks our range to -0.5 to 0.5. And then if we add 0.5 to our range, we've shifted it from -0.5 to 0.5 to 0 to 1. I hope that's clear how that works. Okay, so let's go ahead and plug these values in. And what you can see is we've now created this animated blinking pattern. Because we're taking the sine of time, we're blinking or oscillating between 0 and 1. So if I wanted to create an animation that had a blinking light or something like that, I could do that with the sine of time and then adjust the range so that instead of between -1 and 1, now it's between 0 and 1. Pretty cool. And if I want to make it oscillate faster, I can just multiply by a value here, like, I don't know, something like 10, pass that in, and now we have a really quickly blinking light. So, pretty simple basic example. Let's take a look at maybe something just a little bit more complicated. I'm gonna move down here to where I have these nodes. Now you can see that I have this texture gradient, and this is basically just a radial gradient that I created in Photoshop. And what I'm doing with this example is I'm creating some ripples. So I have my time node, and I pass that through a fraction, which means time goes from 0 up to 1 and then jumps back to 0 again. And then I subtract 1 from that, and I add the result to my gradient. So the result of these nodes here looks like this, where I'm just cycling through my gradient, and because I'm subtracting it here, I get this like slowly cycling pattern. Okay, then I multiply by 8. And the reason that I'm doing this is just to sharpen it up a little bit to increase the contrast. And so now I've got a pattern that looks like this. And then I clamp the value between 0 and 5 because I'm multiplying by 8 here. My maximum value is 8. Clamp the value between 0 and 5. Then I multiply by pi. And that's giving me this nice animated circle here. But I don't want a solid circle, I actually want ripples. I'm creating an expanding ripple effect. And so then I pass the result of that into my sine wave, and I get this result here, which is extremely hypnotic. I hope if you have problems with patterns like this, you can look away or something. But I'll pass this into my master stack, and now you can see that I get this nice ripple pattern. Let's take a look at it on a cube. That might make more sense. Okay, so I'm able to use this to create ripples in a pond, for example. And I actually did create another tutorial video where I went into depth on how to do this effect. So if you want to take a look at that one, I'll put the link to it right here in the upper right corner. Now, the one thing that I do want to point out here is that we're using sine wave again to create a wave pattern. Right here we have a solid pattern with a maximum value of something like 15 because we're multiplying our 5 by pi. But then when we pass that into the sine, it creates these waveforms just like we talked about before. So, pretty cool. All right, let's take a look at another example. In this example, we're using the sine of time as a wave animation to actually animate our model. So instead of animating the color between 0 and 1 or black and white, now we're animating the position. You can see I've got the position of my vertices in object space. I use the split node to split out their x, y, and z position coordinates. And then I take the sine of time and add that to my y position. And then in my master stack, I pass that into my vertex position node. So I'm able to animate the y position of my object up and down, and you can see that because it's a sine wave, it's doing this really nice, smooth oscillation. Well, what if I wanted to turn this into a bouncing ball? As we said before, sine goes between -1 and 1. And in order for a ball to bounce, I just want it to go between 0 and 1. And so what I'm going to do in this case is I'm going to use an absolute node. And what an absolute node does, we may talk about more of this in the future, but it basically turns any negative values into positive values. And so as I go below 0 into negative territory, it's going to turn those negative values into positive values. And now I have a ball that looks like it's hitting the ground and bouncing because my sine wave's negative values are being turned into positive values. Okay, so far we've used our sine node to animate color or brightness value, to create ripples, and also to animate or oscillate the position of our object. In our next example, we're going to use sine and cosine to rotate our texture coordinates. Like I said, in this example, we're going to be rotating some UV coordinates. And I know that this graph looks a little bit complicated, and so I'm going to take a minute to explain what's going on. Here are my incoming UV coordinates. And then I have a vector 2 here, which represents the center point or the pivot point around which I want to rotate my UVs. And then this value down here represents how much I want to rotate them. Okay, so first of all, I start out by subtracting out my center point or my rotation. And then at the end of the graph, I add that back in. So by default, my rotation is going to be around 0, 0, which is down here in the lower left-hand corner. And that's not what I want. So first I need to subtract my pivot point to center it. And then at the end, I need to add it back in. So that's what I'm doing here, subtracting it out and then adding it back in. So I shift everything to the center and then I get rid of that shift at the end. Now this branch of my graph is transforming or rotating the u coordinate of my coordinates. And this branch of the graph is rotating the v coordinate. And then I bring them together here with this vec2 node. So you can see that I'm taking the cosine of my input angle and I'm multiplying it by the x or the u coordinate. And then I'm taking the sine of my input angle and multiplying it by the v coordinate. Then I'm adding those together and that becomes my new vector 2. And then I'm doing sort of the opposite for the u. I'm taking the v coordinate here and multiplying it by the cosine. And I'm taking the x or the u coordinate and multiplying it by the sine. Then I'm subtracting the result of those. If we take a look at our results in the intermediate steps, you can see both my u coordinate here and my v coordinate here. Let's pass in, just for fun, instead of a static value, let's pass in time for my rotation amount so that I can animate this. And now you can see that my u coordinate is rotating like this, and my v coordinate is rotating like this, and my results look something like this. Now I know this is kind of complicated to set up every single time you want to rotate some UV coordinates. And so I have some good news for you, and that is that the editor has a built-in node for doing this called rotate. So here is my rotate UVs node, And just like I'm doing with all of this, I can pass time into my rotate value here and get the same result from my rotate node as I'm getting from all of these graph nodes. So basically what I've just showed you is this is the graph, or this is the math that's happening inside my rotate UV node. So we can see that I've got my results synced up just right. The rotate UV node is doing exactly the same thing as all of this. But what I wanted to show you is that you can use cosine and sine together to rotate your U and your V and end up with some rotating UVs. And then you can, if you were to apply a texture and use these UVs to sample that texture, you would then have a rotating texture. And this goes off the principle that we looked at the beginning, where sine and cosine are complements of each other as my radius or my point goes around that circle. That's kind of what we're exploiting here in order to be able to rotate our UV coordinates. Pretty cool. Okay, let's go ahead and switch over to Unreal now and take a look at these examples in that engine. Here we are in Unreal with the same 4 shader examples that I showed in Unity using the sine and cosine nodes. First of all, we have the sine of time that I was using to do our little oscillation between 0 and 1. And so I'm going to plug that into our color values here. And what you're going to see here is now that we have those plugged in, we're going to get this oscillation between 0 and 1. Now there is one interesting thing about the sine node that I need to point out that's a little bit different from the way that we generally think of sine. Usually in math, when we call the sine function, it gives us a value that has a period of 2 pi. And the 2 pi period is just something that's assumed. But Unreal actually exposes this period value here, and you can type in whatever you want. Now, it defaults to a period value of 1. So if you want the sine node in Unreal to behave like other game engines or math formulas would, you need to give it a period of 2 pi, which is 6.283185. So in each of these examples, I've had to type in this value because it defaults to 1, which means you're going to get different results than in Unity or in other places where you're doing math. So usually when I'm using the sine value in Unreal, I'd be sure to give it this 2 pi value for the period. Okay, so now that we have a value that's oscillating between negative 1 and 1, again, we need to multiply by 0.5 and add 0.5 to shift our range from negative 1 to 1 to 0 to 1. And now that we've got that done, I can plug these results in, and now we're going to have a value that oscillates between 0 and 1. Okay, in our next example, we're creating the ripples using this radial gradient texture. So I'm taking the fractional portion of time, subtracting 1 from it, and then adding that to our texture. And if we plug this in, you can see that we have this animated gradient here. Well, we're going to take that value and multiply it by 8, and then clamp between 0 and 5. And that's going to give us a gradient that is a little bit more solid. And then we're going to multiply that by pi and pass it into a sine wave. And that will give us our waving values because the sine wave is oscillating back and forth between 1 and negative 1, going up through the values that I'm getting as a result of the rest of this function. So the sine wave is able to give us these individual ripples. And then if I wanted, I could take what I've done here and expand on it to create ripples in a pond, for example. Okay, in our next value, we're actually animating the position of our object here. So I'm going to switch it over to a sphere just so we can see it a little bit better. So I'm taking the sine of time, and in this case I have to multiply it by 100 because the position units of Unreal are in centimeters rather than meters. And my sphere here is just a little bit larger than a meter. So if I want values that aren't tiny, I have to multiply it by 100. Then I'm going to pass that into the Z component of my append many because, again, Unreal is Z up instead of Y up. In Unity, I was animating the Y axis to make my ball bounce vertically, but in Unreal, I have to animate the Z axis. Okay, so I'm going to pass this value then into my world position offset. And now you can see that my sphere here is oscillating up and down because of the sine animation that I'm adding to its z-axis. So that's pretty cool. In the example that we showed in Unity, I showed how you could take the absolute value of the sine of time to make the ball look like it was bouncing. And so we're going to do that here as well. If I just pass the sine of time into absolute value, then when my values are trying to go negative, instead of negative, they go positive instead. And I get this bouncing feature. All right, and then just like in Unity, I've got this for rotating my UVs. I have this built-in node called Rotator, and it follows that same graph pattern that I showed you before using sine and cosine on the U coordinate and also cosine and sine on the V coordinate to rotate my texture coordinate. So just like in Unity, in Unreal, we also have this rotator node that handles all of that for us, so we don't actually have to build that graph. So I'm going to plug my texture coordinates into my rotator. Then I'm going to plug my time into my rotator as well. And so if we take a look here, you can see that now I've got my UV coordinates animated. And just like in Unity, all of the math, including the sine and cosine operations, are happening inside this rotator node to rotate my UV coordinates. Okay, that about wraps it up for our examples for today. I hope that this was interesting for you and that you learned how to use the sine and cosine nodes in a bunch of different examples, oscillating back and forth between black and white, creating some animated ripple values, animating the position of our object up and down in a wave and also bouncing, and then finally rotating UV coordinates using sine and cosine. I hope you guys have a great week and that you come back next week. We're going to be talking about the power and square root nodes. So come back for that. And in the meantime, have a great week, everybody. Thanks a lot for watching.